Welcome to part 9 of the Gloomwood inventory tutorial. In this part we're going to go over grabbing and basic movement. So this is not going to be complete, so once you're done with this you won't be able to do all the placement and all that perfectly, but we want to get the start of that set up now because it does take quite a lot of time. We're going to try and cut it down into nice little parts so it's easy to follow. But before we get into that, I actually want to fix a few things that I messed up in the last 2 or 3 previous parts that I just forgot to fix. So the first one is, in one of the previous parts, we actually used our editor utility widget to make a new item. So I'm just going to open it up here so I can re-show the error. So if we run this and let's say we want to make a new item and we put in, before we say, oh, we want it to be this shape. So any shape is fine. And if we start typing in information here or do anything at all and then click here, it hides those slots. Now, they're still selected because if we left click here, it doesn't do anything. And same thing here, but if we click here, it does. So it knows these are still selected, but visually there's a bug. And so the solution to that is if we go and open it up, so double click EU item creator, and inside of our graph, the issue is we are calling all of this on pre-construct. And so for some reason, I'm not exactly sure why this is, but pre-construct gets called even if, for instance, you click here or you change this, it will call pre-construct. So if anybody knows why pre-construct gets called there, that'd be perfect if you could let me know. I'd love to learn. But it causes that issue, and I'm not sure why. So instead, we're just going to move this to our event construct. And now if we do the same thing again, so we're just going to close it so that it resets properly, right click, run editor utility widget, and let's just select these 5 here, try again. If we type in a name and we click somewhere else, it still keeps the shape. So there we go, so that's fixed. That's one of the fixes out of the way. Now next is one that we did in the last part, which is our chest. So if you notice, we open our chest, it works just fine. If we close it though, it zooms out, and then only once we're all the way out, it starts closing, which isn't correct. And the reason we have that error is because in our suitcase here, if we go down to our set position for the close inventory, we set it to 1 because 1 was the end of the animation, but that isn't correct. 1 is the point in time during the animation where it is at 1 second. So if I open up the animation we are using here, let's just pull this up. What is happening is when we say set position here with this, and we're saying 1 is placing it at about this point right here. So pretty much 1 second. But the animation itself, as you can see, doesn't change here. It only changes at 0625. Here is where it actually starts or ends. So this is my fault. It's a problem on my end for having actually screwed up the export. So to work around that, we instead put in position here 0.625, pretty much the same number as we have for the blend time and for the delay here. And we just do that instead. And now if we play again, if we go and open it, just fine, and we close it, it starts closing immediately. So that solves our second issue. So let's just save that. And so finally, the third issue we are going to solve today, before we get into the actual video, is in our AC handler, we made isDragging and we made IsInInventory. And if we pull both of these in, they're both called isDragging, which I completely missed when I actually dragged the IsInInventory in and left isDragging. So this could potentially cause an issue for you visually, but if you go from here, it will always be the correct one. So to change this, we need to go and select our IsInInventory, change its comeback title from isDragging to IsInInventory, and that will change it. So now we can actually tell the two apart. So let's close both of those, and we can now finally get into the actual part of the video itself. Okay, so unlike usually how I do this is I'll go and say, these are all the functions we need, and then we work our way through each function one by one. This time I'm going to take more of a function by function order based on what we actually need to get this to work. So we're going to start where you would expect to start. It is the button. We're going to start with our press. And our press is going to need two things. So our drag here, IA drag, we're going to remove our print because we know that works from last time, and we're going to get two new functions. So we're going to make a function called try drag item. Then we're going to make a duplicate of this, which we're going to call try drop item. So close this, and on started we'll call try drag item, and on completed or cancelled we're going to call try drop item. So make sure you have completed as well, because cancel could be if we remove the player input, completed is if we just let go. And let's start with try drag item. So the first thing we want to do is we're going to check, are we hovering an item? Because if we are hovering an item, that means we can pick something up. We want to get our variable called get hovering item, which I've put in the category for it. So pull this in, and we want to convert this to a validated get. This is the first thing we want to do. So we can run a test here, very simple, just add a print, and we'll be able to see if this works immediately by doing play, tab, and if we left click here, nothing happens. If we hover an item, we left click, works just fine. And it also works for the one outside here if we left click, because it is still an item. Now next we're going to have a few, normally here we're going to have a few checks to see if we can pick up the item, and some other things, some other functions we're going to call based on if we're in an inventory or not. But for now, we're just going to focus on dragging the item, so we're going to ignore those. So we're going to assume if the hovering is valid, that means we start dragging here. And so if we start dragging, well, we have a drag variable we made last time. We're going to get this drag variable. We're going to set it to our hovering item. Now we're going to have another function, which we will call start dragging item. And so in our try drag item, that's going to go right here. And I also forgot, but we do want to have a return here. And it's going to have a boolean just to confirm whether we succeeded in the drag. Call this success. And it's going to be true here. And if it's not valid here, this will be false. Okay, so technically right here, we're pretty much done if I'm not incorrect. Because if we click here, as you can see, we've picked up the item. Now, this is not what we want, obviously, because as you can see, it doesn't really work. We're kind of just, what's happening here is we are dragging the item and hitting the item itself, so it's going constantly hitting us in the face. So the first thing we're going to do to fix that issue is inside of our start dragging item, we are going to say get dragging item, and we're going to tell it to have its collision disabled. So we're going to say set actor collision to false. And normally now if we do the same thing, we won't have that same issue. There we go. So that works just fine. So one issue that we just had that I just realized is if we play right there and we pick up the item, I can't move the mouse here. The mouse just refuses to move, and the reason is because the cursor is hiding. Technically, that's what you would call it. And as you can see right now, I let go, I'm no longer clicking, and I can move again. So that means our event tick is working, and the movement does work, but there's an issue. And that issue is the fact that if the mouse is hidden, like when you left click, it doesn't consider it able to move. And so the solution to that is very, very simple. In OpenUI in our event graph, uncheck hide cursor during capture. That's all you have to do. And now if we go and try again and click, we can move while holding the mouse down. Okay, so that pretty much does it for our drag, so to speak, that very simple system that we just did. Really, really simple. We're just going to add our drop, even though our drop item can't do anything yet. And so we're just going to duplicate our start dragging item and call it stop dragging item, or drop item would work as well. We're going to set the collision to be true, and we're going to call it in our try drop item. So we're going to just say here stop dragging, and we're going to return true. So same thing as before, because it's a try drop, we want to say it succeeded. Now the only issue here is right now we could do there's a lot of stuff still to do, a lot of difficult and complicated stuff to do, but instead of doing that, I think I'm going to focus on kind of expanding what we already have first, and then we can compile it all together, let's say next part. So we're going to open our 3D inventory. So in Blueprints, 3D inventory. Okay, so one thing I just realized that I missed. Right now, if you run this, as you can see, our mouse is hovering the slots, but there's no change. Normally the slot should become slightly darkened because our mouse goes over it. So to do that, normally you would expect you hover the mouse. It works. Now, that is true. I just forgot to do it. So let's open our suitcase, and in the suitcase, if we select our widget interaction, we can actually change this, the interaction source. And if we change this to mouse, and we say compile play, then now you can see that it's actually getting darker because our mouse is going over it. And this works here. Obviously, our mouse is on the item, so it doesn't work anymore. But you can see that we are actually hovering it correctly. And if we drag, same thing, it still applies, it still hits those points. Obviously, right now we can't hit there because an item is in the way. Now, the reason it just jumped back is because we reset the collision, so it just bounced back immediately and caused an issue. Now, one other thing I just realized is in our handler for now, I forgot in our stop dragging, we should also say dragging item gets set to be empty. Otherwise, we'll just keep moving it. So let's try that again. If we drag and drop, the item just kind of stays there. Now, obviously, we're going to make it so that it snaps to its coordinates and all that later, but this is where it's going to stay for now. So what we'll do is we're just going to go into our different ones, and we're just going to say interaction source mouse. We're going to go in our chest, do the same thing, select our widget interaction, and we're going to say mouse. And there we go, because we only have those two. We can now move on. So if we go, let's say over here now, open our inventory, we can actually hover these slots as well. Works just fine. Okay. So the next thing I think we're going to do for this part has nothing to do with item movement at all, but it is very important for the setup of this whole thing. So we are going to go into our blueprint interface, our BPI. So that is in our structure and BPI share. And we're going to make two new functions. We're going to make a function called bind events to handler. We're going to add a input for the handler here. So this is going to be AC handler. And then we're going to duplicate it, and we'll call this unbind instead. Unbind events from handler, obviously. And so what we're going to use this BPI share for is we're going to use it as a means with these two functions to create event dispatchers in here that say, for instance, the item just entered an inventory, the item was just dropped, the item failed to drop, the item needs to be reset. Those different options will be called via event dispatchers. That way, if one, we can bind them to our items so that our items readjust its location all internally, so that because the item itself knows its static mesh, it knows what its size is, it knows where to move, so it can handle itself locally. But in addition, we can also say, well, maybe the player wants to do something. If this happens, if the item resets, maybe it wants to call any dialogue, and we can't do that from the items, but we can do it via here with event dispatchers. So that's kind of why we're doing a mix between blueprint interfaces and event dispatchers further down the line, and why it allows us to completely avoid any hard references to the A items themselves. And this obviously also allows you, if you want, to make your own items completely different and have a completely different system, but that still can connect to the handler. And obviously the 3D inventory as well, and the AC inventory as well. So I think the next thing we're going to do is we're going to start somewhat our... I think we'll start working on our try drag and our start dragging. We'll start making our way through it. I think we'll have to stop halfway because we don't have most of the stuff, but we'll get some of it out of the way now at least. So we just made, as I mentioned, our bind events. So we're going to start using them. We're going to get our dragging item and we're going to call bind event to handler. And the reason we do it this way is now we, on instantly picking up, we get to say, okay, the item is connected. It should start running the functions once the things happen. So we'll add self as the target for the handler, because obviously this is the one controlling it. We're just going to do a reroute here. We're going to right click. We are going to turn it into a function. Call this get grab coordinates. So the first thing we want in get grab coordinates is we want to call our function line trace from the mouse. And we want to use this information here by breaking. And we're going to make the assumption that obviously it already hit something because we are dragging. So it should already have something in its hand. And we're going to say impact point minus normal right here. And we're going to save our hit actor. We're going to save our hit component as variables. So we're going to promote this to a variable we will call L impact point. And this will be our hit actor. So promote this as well. L hit actor. Sorry, no, we don't need hit actor. That's our dragging. We don't need that. But we do need our hit component. So get our hit component here and store it as a local variable. L underscore hit comp. Let's just rename that here to L underscore. Get rid of the hit actor and collapse this. Line this one up here. And we'll just move this one here. There we go. Okay. So just so I explained, the reason we're doing it this way and not, for instance, saving a variable here and using the out hit, saving it and then recalling it here, is because our try drag item isn't being called after a line trace. So this variable might have changed in between the time that this gets called. It's very unlikely because obviously this is going to be in a tick and this is going to be called instantly. So the chance of it happening is very low, but still it's best to not do that, or it's best not to call things separately. So let's get into this right now. And we're going to need a few extra variables as well. So we're going to start with our dragging item here. We're going to get its shape. And with the shape, we are going to get the max values. So not our max values, so our range. What do we call it? Shape span, sorry. And so we're going to save our X here. So promote to local L underscore X span. And we'll do the same thing for the Y. Promote L underscore Y span. There we go. And so with this, we're going to do a bit of math to determine where we clicked. So what does that mean? That means, for instance, if we have our, let's say our L shape here, when we click on it to pick it up, we need to know which cube pretty much we clicked on. And the reason we need to know that is because we want to make sure our item when we pick it up doesn't just keep being stuck to, for instance, our mouse here and stay like this, but actually goes and kind of sticks itself to where the mouse grabbed. So if we click here, it'll move relative to where the mouse grabbed it instead of just immediately teleporting back to the left. It just gives it a kind of more nicer feel to when you pick up an item. So back into our AC handler. And how we're going to do this is we are going to get our component that we just, not our component, our comp, we called it. Our local comp here. And we are going to get its world transform. And with this, we can then convert our impact point, and convert it to be in local space. And so that means we can say inverse our location, and that will convert our impact point from world space, which any line trace automatically is in world space, and pass it into the local space of the actual component we hit. And by the way, I forgot to mention this. The reason we say impact point minus the normal is because if we do impact point alone, it would consider it here on the surface. So it would say this is where we hit, for instance. But if, let's say, you have it here on this surface, it might consider it to be -1, when in reality it's 0. So instead, to avoid that issue, we just say, oh, well, where is the normal facing? What's the opposite direction that we just hit? And that would be outwards. So we subtract it, meaning we go inwards. So we're always slightly within that cube, within that area. So it will always be a valid point no matter where we click. Okay, so back into our AC handler and let's keep going. So once again, this converts into local space. We want to convert this to 2D because we absolutely do not care about the Z, doesn't matter. So we're going to say 2D, so 2 vector 2D. And then we're going to divide this by our scale, our grid scale, to speak. So what we want is we want to get our class defaults that I've mentioned before, And we want to change this from AC handler to our game rules right here. And what we're looking for is our 3D grid size right here. So just disconnect the 3 here, plug this in. And so now instead of having our world coordinates, we have our local coordinates. Then we have them in 2D. And then we've just divided them by the size of the grid. So now we actually have them in coordinates instead of having them in location. And by coordinates, I mean the shape, pretty much, the shape coordinates. So now we need to convert this from 3D to 2D. So we break our 2D vector and we convert this by saying make 2D. And we plug in our X into the Y. And for the new X, we can't just plug this in directly. We need to turn this by saying minus the X span. Sorry. Yeah, get the X span, sorry. So get X span and plug it in on the top one. And then plug this into the X. So this is acting as a 1 minus to invert the distance. And so finally, one last thing is now we need to make sure the values are maxed out or clamped, so to speak. So to do that, we are going to break this once again. And we are going to say floor. And it's very important, specifically we use floor, not truncate, not seal. We want to use floor specifically. And we want to say that we want to clamp this integer, clamp these to our X span here, -1, because obviously these are coordinates. So our span is not what we want. So make sure it's between 0 and our span. And we can just copy this, put it below for our Y. So plug in the Y. And instead of X, we want to right click and replace this with Y span. Then we're going to say to float because we want to convert these back into a float so that we can use a 2D vector. And put this here as well. And now we can say make 2D vector. And this is going to be the output of the function. So we're going to get a return node. Plug this return value in here, and we are done with this system right here. This is for getting the local coordinates. It's the place where we grabbed it. Where did we click the item on its local space? And so we're going to promote this to a variable that we're going to keep, and this is going to be a normal variable, which we're going to call relative coordinates. And this is very important. We're going to use this a lot. And I think we're going to leave this here because that took a lot more time than I thought it would. But we're just going to test if this works by adding a print. And we're going to have to check the coordinates. And also, I just want to specify, because if you've been paying attention to all the other parts, usually we rotate the grid here. Usually we rotate the shape, but in this case we don't. And the reason for that is because this local space doesn't care about the rotation because we're using the component. So that means it's always going to be considered 0 in rotation. So we don't bother with changing the shape, we just use the default shape. And later down the line, when we do use this grab coordinates, then we'll convert it to the rotated version when we need it. So if we just test this by adding a print here, by connecting it, and if we go and just try and pick up any old item, we should get a print with the coordinates. So if we go and left click here, we get 0, 3 on the Y. If we click here, we get 0, 3 as well, 0, 3 as well, and 0, 3 as well. So that's incorrect. That shouldn't be doing that. So for some reason, I'm not sure why, but we're getting negative coordinates here every time. So I'm not sure why that is. I know. I think I know why. The reason is because of this. Because we've been telling it to disable its collisions before we even line trace, it hasn't been managing to hit it. So if we do that instead, we should get a better result. So there we go. So now it's actually hitting all of the different points correctly with no issue. Still teleporting obviously back to the beginning because we haven't said anything else up there. But if we click on the different parts, it actually says right now, for instance, it says 2 on the X, 1 on the Y. So that's 0, 1, 2, and 0, 1. So that does indeed make it 2 and 1. If we click here, it should be 1, 0. and we do indeed get 1, 0. Here it should be 0, 1. Also working. If we click here, we should get 0, 0. If we click at the bottom, it should be 3, 0. So it's working just as intended. That's great. Thank you so much for watching this part, even though it wasn't maybe as interesting or as movement based as we probably were thinking. We managed to make some progress on the whole thing because it is very, very messy. This is just one of the so many functions that we're going to have to go through. So thank you for watching. I will see you in the next part. If you want to get these parts commented, they are in the description or on the Patreon. Thanks to everybody who is supporting me on Patreon, and I will see you all in the next part. Goodbye.